Problem 8. Sometimes one of the things that stands out about a problem is not what they show you, but a lack of showing, like a void. And we have no diagram to help us. And that's going to be our first task, is reading the problem, figuring how do we draw and what do we draw. So if I just start, I'm going to notice it says, hey, you've got a right triangle. So I'm going to make that look very right, 90-degree angle. And I'm not going to label it ABC yet, because I need to know where A goes. Is A going to be the 90-degree angle, or is it going to be something else? And it turns out A is something else. And I can put that A wherever I want. That's not too important. But what I will focus in on is B. That 90-degree angle needs to be called B. And once we've gotten that down, A could go up here, and we know that's 32, and that leaves just one more spot for C. Okay. I could figure out C if I wanted. I could take 90 and subtract that 32 to figure out its complement, because I know these non-right angles in a right triangle must be complementary, must add up to 90, because the remaining 90 is over here. But I think I'm kind of getting a little off topic here. So let's keep on going. We did that. Ooh, yeah, I remember this problem now. It says AE is 6.2. That's a typo. That should be AC. So we're going to rewrite that as AC equals 6.2. And then it says, what is the length of BC? Rounded to the nearest tenth of a centimeter. So AC is 6.2. And they want to know what's the length of BC. They want to know what's the length of this side. So I've got everything labeled. I see I have an angle, and I see I'm looking for a side. That's trig. All right, trig is the relation. It's the relationship between sides and angles. All right, and that's exactly what this problem is. It's like, how can this reference angle of 32 tell you something about the opposite side when you use the hypotenuse and the correct trig function? So when I have hypotenuse and opposite, that's a sine trig function. That's opposite over hypotenuse. And the angle that I'm going to use is 32. My ratio is going to be the opposite x divided by the hypotenuse, 6.2. I'm going to turn sine of 32 into a ratio. So I can butterfly multiply and get x, and then I'll have the trig function goes at the end, right? That sine of 32 should be wrapped in parentheses, right? Guarded in parentheses, and then put that 6.2 in front of it, right? Because it's 6.2 times the sine of 32, and that all needs to equal x. I just forgot to put down my equal sign originally. So if I look at the work that's on my paper, x, right? X equals 6.2 times the sine of 32. So I don't have to do any algebra. I just gotta type it in the calculator. It already says x equals, so it's 6.2 sine of 32. And that's when you connect, and that's multiplication. So it turns out x is about 3.285. X equals 3.285. And they wanted it to the nearest tenth. So I'm going to look at the 10th spot, and I'll look to the right because that's 5 or higher. I'm going to round that 3.2. I'm going to round it up to a nice 3.3. And that will be the length of BC.